Hello everyone. Today we will discuss about on the basis of those chemical properties, um, we can divide of any layer elemental concentration within that layer. So that means the mineralogical composition, and within that particular mineral, what are the elements present, their concentration basically guide us to separate rock layers from another layer, as the mineralogical composition of different rock layers varies. So depending on that, the elemental concentration of different rock layers will also vary. And from this concept, the study of stratigraphy on the basis of the elemental concentration within the layers is done, and that is known as chemostratigraphy. So basically, chemostratigraphy utilizes changes in bulk, inorganic, geochemical, chemical or elemental data. And we all know that the mineralogy within the sedimentary rocks or within certain rock layers varies due to some conditions. The mineralogical condition can vary due to the difference in provenance, that is the source area compositions. The mineralogical composition of any layer varies due to different weathering or diagenetic processes occurring after the deposition of their layer. Weathering is basically the cause for fragmentation of the sedimentary particles from its source rock. So if physical weathering is more prone, then certain types of fragmentation of minerals will happen more. If chemical weathering is more prone in an provenance area, then certain types of um, fragmentation of minerals will happen more. Similarly, different depositional environment can go to different diagenetic effects. So due to these two factors, weathering and diagenesis, uh, the ultimate elemental concentration or the ultimate mineralogical composition of any layer will vary. And lastly, the environment of deposition. So certain particular environment are favorable for particular mineral deposition. So in every environment, every mineral cannot be deposited. So if the environment, suppose if the environment is very much acidic and it is aquatic, then the carbonate mineral is most likely will not precipitated, will not deposited. Okay, so like this way, these three factors are the main guiding factors by which the mineralogical composition within the sediments and ultimately the elemental concentration, elemental composition within the sedimentary rock layers will vary. Now here is an example how the elemental concentration will depict us certain phenomena. In chemostratigraphy, we are not only considering the elemental concentration of any particular element, but also sometimes we use the ratio between two different elements and their variation through time. Suppose in this picture you can see that here the data of is plotted with time, and the data is basically K2O is to Al2O3, potassium oxide is to aluminum oxide ratio is plotted with time. Now, when this ratio is showing much higher values in the rock layers, that indicates that there is more chemical weathering happened during that time. So here you can see that in this gray color band or gray color layer, the K2O by Al2O3 ratio is much higher than the yellow band and this light colored bands. So during the deposition of these gray color bands, chemical weathering is more intense than deposition of these two layers. Similarly, here also the ratio between TiO2, titanium oxide, and zircon is plotted, and it also shows when the ratio of TiO2 by zircon is high, that indicates that the provenance rock is either a granitic rock or a basaltic rock. That means a igneous source rock is determined by the higher values of TiO2 and zircon. So again, you can see that in this gray colored portion, the ratio of TiO2 and zircon is high. So these minerals or these detrital uh, fragments, detrital sediments are coming from a granitic or basaltic source rock. Whereas in these two cases, in the yellow, in these bottom two layers, the source rock is less likely to be granitic or basaltic. There might be some other source rocks, but here in this gray color band, the source rock is more and more likely to be granitic or basaltic. Similarly, when any single element is concentration is observed, suppose the concentration of magnesium oxide, when the magnesium oxide concentration is high, that indicates that the rock suffers a pronounced diagenetic alteration. That means alteration during diagenesis, during the solidification stage of the sedimentary layers. That means these kinds of change occurs after the deposition of the sediments during its solidification process. So the higher concentration of MgO occurs due to diagenetic alteration, but here in these cases you can see more or less uh, MgO concentration is more or less almost fixed. That means diagenetic alteration in these cases are very poor. Only in this portion you can see that the MgO concentration is certainly becomes very high. That means during the deposition of sediments in this time interval, the sediment suffered a major diagenetic alteration, and that diagenetic alteration can happen due to various reasons. So like this way, the geochemical signals or the geochemical properties of the rocks or rock layers helps us to identify different um, incidents during the deposition of that particular rock layer. Sometimes it will depict as the depositional environment um, in terms of diagenetic effect. Sometimes it gives us result about the provenance. Like this way, we use the different chemical uh, properties or different chemical signals of any rock, and from that we try to understand the paleo environmental condition of deposition of any particular layer. And by studying layer by layer this chemical change in properties or chemical change in mineralogical composition, we ultimately try to depict the paleo environmental changes through time. So chemical composition of sediments can be highly variable depending on the source rock. However, secondary processes like weathering, diagenesis can have an effect on chemical composition of sediments. Therefore, one best relies on elements that show little mobility in gas sectors, particularly this chemostratigraphy, that means the chemical concentration of minerals, are very useful tool for petroleum industry. Certain particular presence, chemical presence or elemental presence indicates the presence of coal, indicates the presence of petroleum. Okay. So these are very much helpful for mining industries. People have to study. So that's all. That's a very brief. introduction of chemostratigraphy. Thank you.